right, so good morning, right? So last week, you guys remember that we were working with those problems involving equations. We were substituting in values and figuring out which value worked for the equation. All right, so ideally last week, you guys already went through the last couple of slides that I'm about to go over. I'm just going over it in case anybody had any questions. There's only a couple of slides left, so today's actual lesson should be pretty short. I don't imagine it will take more than 15 or 20 minutes. Then I figured, like last week too, we'll play a game of Kahoot together just to practice those skills of working with equations, all right? Also, it's week 5, right? So this is our last full week of summer school. Next week, it's only Monday and Tuesday, all right? So just keep that in mind. We're almost done, almost out of the woods, all right? You guys will have a full month off before school is supposed to start in whatever capacity that is, right? So remember, last week we left off on this here. It was basically just you guys doing the same thing that we did, looking at a couple of different equations, like this one over here, substituting values in to see which one made it true or false. Just anybody let me know if you had any questions over here before I move on so I can try to help you out. And also just don't forget to do these self-evaluations at the end, just to rate yourself on how you're doing with the material so far, right? But I'll come back if anybody listening that you have some questions. For now, I'm going to continue, right? So we're really just going to see 2 more examples, just like what we did last week, right? So they like to give us these word problems to try to help give us context to these scenarios. And it's good to read through them to understand it, to figure out how they're making these equations so that once you're tasked with doing this yourself, you kind of have an idea of, okay, so let me multiply this by this, let me add this, maybe put parentheses here. So you kind of learn by example, all right? So in this example here, it's saying that Sarah bought 2 packs of frozen chicken at the grocery store. So I'm just gonna highlight any text that seems like it's gonna be important, right? It says that her brother Richard bought 3 packs of the same brand. So Richard bought 3 packs of the same brand of frozen chicken. They apparently like a lot of frozen chicken in this house. And a price that was $2 per pack less than what she paid, right? So this part of information is actually important. It costs less money than how much she paid for it. It says altogether they paid a total of $29. How much did each pack of frozen chicken cost? So again, this is an example where for some odd reason, they went to the store, they don't know how much it cost, but what he does remember for some reason is that what he paid was $2 less than what she paid, right? So they generated for us this equation right here, and just really quickly, I wanna just make sure that we understand what the different parts of the equations mean here, right? So we know that they spent a total of $29, right? So that's over here. Usually when you see a word like total, that tells you that you're gonna have an equal sign. So everything that they spent is equal to $29. Now, we also know that what they're doing here is they're letting the variable B, sorry, that's a terrible B, represents the price of the chicken. I'm not sure why I can't write today. Sorry guys, it's early Monday morning. So Sarah bought 2 packs of frozen chicken. So if it costs B dollars for each pack of chicken, she's gonna spend 2 B dollars. Now, we also know that her brother bought 3 packs of frozen chicken. So if you're not paying attention, you might say, okay, so it's just 3 times B. But we have to be careful, right? Because that chicken is $2 less. So if, you're getting confused by the variables, think about an example. Let's say that, for example, what if we said, okay, maybe the chicken costs $10. If the chicken costs $10, that means that what her brother spent would end up being $8. So whatever price she spent on the chicken, you subtract $2 to figure out how much money her brother spent, right? So that's why we have this B minus 2 here, right? This B minus 2 here represents what's the cost of the chicken after we take off those $2, all right? So this is our equation here, 2 times B plus 3 times B minus 2. And remember, when you see parentheses over here, be careful. That's a sign that you're gonna have to do what? Can somebody let me know in the chat? What did we talk about last week that when you see something in this with parentheses that tells us we're going to have to do something, it starts with the letter D. And I'll just wait for somebody to give it to me. Right? That means that you're going to have to distribute. So usually when you see a number with the variable inside parentheses, that's a sign that you're going to have to distribute something, right? But we're not worrying about distributing today, because what we're actually going to be doing is just substituting values in, right? And I don't think I'm going to spend too much time just going over this. I'll go over the first example, remind us how it's done, and the other ones are listed here, all right? So we're distributing, sorry, we're not distributing. We're going to say, okay, so could the price be $5, right? To see if the price could be $5, you say, okay, so this is our equation here. We substitute, sorry, remember they're going to, again, they say here plug in, but the correct mathematical terminology is substitute. So I'd substitute this $5 in for this B here, and also in for this B here. So all that means is I would rewrite this scenario and I would say, okay, so that's 2. Remember, if it's next to it, that means multiplication. So that means 2, I have to write the multiplication once I substitute. Otherwise, it's going to look like I'm just writing 25. So 2 times 5 plus 3 times 5 minus 2. Remember, what we're doing is we're checking. We're trying to see, is it in fact true that this here is equal to 29? So what I like to do is I like to put a question mark. I say, are these two statements the same? And then all we have to do is, like we saw 2 weeks ago, we follow the order of operations, or PEMDAS, right? Just remembering that multiplication and division are in the same bucket, along with addition and subtraction. So whichever one you see first, left to right. So I'm going to go through this a little bit faster. Remember, first, I would do this here. I would say, okay, 5 minus 2 is 3. So this here, and it might be hard to read over all this text here. Let me try to write it down here. So 2, and a little bit of lag on my pen, times 5 plus 3 times 3. Is that equal to 29? So 2 times 5, I know is 10. 3 times 3 is 9. So I know that 19 is not equal to 29. That's what they have right here. And then again, you would check the next one. You would check $6. You would check the next one here, which is $7. And you're going to find out, if you go ahead and do that substitution method, your answer here is $7, right? So the price of the chicken that Sarah paid was $7. The price of the chicken that her brother paid was $2 less. That means that he's paying $5, right? So hopefully this whole substitution method is making sense, right? Especially once you're looking at, say, multiple choice questions, this is a valid approach that you can use, right? It's not the best approach. We're going to actually see later on that there are faster ways to solve equations like this using algebra, but this is an approach that works, right? And if you have answer choices, it will always give you the correct answer as long as you're using your arithmetic correctly, right? So this slide here, I'm just hoping some people could help me out here and try to match these values on the left-hand side with the equations that fit them, right? So if you're tasked with doing something like this and you're substituting in values, the important thing is just, I would say, to try and make a method to doing this, right? So instead of saying, okay, let's start with, maybe we'll start with the smaller number, because I'm going to look and say, okay, 7, I need to multiply things, subtract. It's probably easier to do that if I start with a smaller number, and by process of elimination, I won't even ever have to use 7 if I figure out the first 3, right? So when you're doing math, try and think smart about it, right? So let's say, okay, let me look at this one here and try to figure out which one it works for, right? But I'm still going to have to try and substitute this into each one of these here to figure it out. So let's start with the first one here. I'd say, okay, so Q is equal to 2. So in this case here, what this turns into once I substitute the 2 is I have 2 plus 2 multiplied by 2. Is that equal to 9, right? Really quickly, I know that 2 times 2 is 4, plus 2 is 6, so this one can't go here, right? Then I would just check the next one. I would say, okay, over here. 4 times, again, q is 2, so 2 minus 2, can that be equal to 20, right? No, because I know 2 minus 2 is 0, so this left-hand side is just 0, so it can't be that one either, right? Now I only have to check one more of these two before I know which one it goes with. So last one I'm going to check, we'll see this one. So 6 times 2 minus 24, is that equal to 6? And I'm going to say no, because this is 12 minus something big, can't possibly be 6. So that tells me that I don't even have to check. I know that this one has to go here, right? But I'm a math teacher, so let's just check it to make sure we didn't make a mistake, right? So really quickly, I'd say, okay, so 3 times 5 minus 2, is that equal to 9? 5 minus 2 is 3, so yes, 3 times 3 is equal to 9. Again, I'm just checking to be thorough, but at this point here, right, once I figured out that it wasn't this one, or this one, if you did your math right, this here has to be the correct answer, right? So I know that this one goes here. You try to figure the rest of them out, right? I still want to give you guys, if you haven't done it yet yourself, the opportunity to do that practice. But is there anybody that was really confused about any of these expressions here? Right, something else to look for, just I want to point out before I go on to the next slide, is that when you see something like this here, something in parentheses where you're subtracting, that sometimes makes calculations easier. So if I'm looking over here, right, this says q minus 2, I know that if I start to put this 2 into here, I'm going to have 2 minus 2, which equals 0. That makes the whole left-hand side 0. Also, I can see this one over here. This is 5 minus q. So if I put this over here, that's going to make this left-hand side 0 as well. So there are going to be some instances where substituting makes things easier if you end up with a 0 or a 1. And that's just some tricks that you guys are going to start to be familiar with and just notice a lot more as you get more proficient with solving these types of equations. All right, but again, if there's no other questions, I'm not seeing any. I want you guys again to just finish that slide there if you haven't yet. And I think we're already actually up to the summary slide. All right, so it says in this lesson, we saw that for an equation to be true, the expression on the left-hand side of the equal sign must be equal to the expression on the right-hand side of the equal sign, right? That's what an equal sign means. It means that you're saying two things have the same value. So it says you can use this fact to check whether a value of a variable satisfies an equation. Again, it says plug numbers. The technical mathematical way of saying that is substitute numbers from a given set of values into an equation to check which value makes the equation true, right? So they gave us this equation here, which actually doesn't look that simple. It says 9 plus 1/2 equals y plus 11. So what you might see is you might see, okay, so, you know, let's say, what if y equals 1, y equals 2, y equals 3? Substitute these values in to see which one of these equations makes this true, right? None of these actually makes this true because of this 1/2 here, right? Y actually needs to have a 1/2 in it as well, right? Just really quickly, is there anybody that thinks that they know what the answer is here? What value of y would actually solve this equation here? And what I usually find, just to give you guys a tip, in 7th grade, you're going to 7th grade, you guys are going to start seeing a bunch of fractions, right? If you're not comfortable with fractions, a lot of students feel more comfortable with decimals. So you can always convert back and forth between the two by just dividing. This means 1 divided by 2. So as a fraction, or sorry, rewriting that as a decimal, it would be 0.5. And Jaden, that's good if you like fractions more. It actually does tend to make things more simple, especially a high-level math classes. You're going to use fractions a lot more than decimals. But what I'm just saying right now is that if fractions like scare you, maybe decimals are easier, right? for now, until you get more comfortable with fractions. So I would say, okay, so that's just, 9 plus 0.5 equals some number plus 11. So this is 9.5 is equal to some number plus 11, right? And at this point here, we're going to say, okay, so how can I add 11 to something and get 9.5? So this something here has to be a negative number, which you are going to spend a whole lot more time talking about in 7th grade. All right, so I'm not going to go over the answer there, but just realize, right, a lot of times in math, you can look at something and try to get some information just by what you see. So some number plus a bigger number than this equals to this. That means that instead of adding, I actually need to be subtracting. And in math, the way that you subtract by adding something is with a negative number. All right, so again, at this point, we have gone over all the slides so far. So what we're going to do is we're just going to kind of practice these skills by playing a game of Kahoot. So I'm just going to stop the recording for now.